So here in 3.6b, we're going to be talking about, again, solving systems of equations with three variables, three equations. In part A, we solved these using elimination. Today we're going to use substitution. Now, if you want to write these down, you probably want to pause it for a second. I'm going to read through these quickly. Honestly, I think they'll make more sense once you've seen kind of what we do and then look back at them. But here's your process. Solve for a variable in one of the equations. Stay away from fractions if possible, and it usually is. Substitute that expression in for the variable in the other two equations. Simplify your expressions and write the two as a system and solve. Then you'll plug in your final variable. Now, same as in part A, I put on here, you probably want to check your work. We're not necessarily going to do that as we work through these together, but it's a good idea for you to do that if you make little kind of careless mistakes. So what we're going to go through and do is we're going to look at two of these. So here's the first one, and then we're going to look at one more. Okay, so looking at this, what I want to go through and do is I want to pick one of the variables to solve for in one of the equations. Now, you're going to have some choices here. You could choose this y right here. It would be pretty easy to solve for. The z here. I'm going to pick the x. There's not a right or a wrong. You'll get to the same place regardless of which one you pick, but I'm going to pick the x. So move the 2y over, move the z over, and my -4 is still there. Okay, now what I'm going to go through and do is I'm going to take the value that x equals and I'm going to plug it in for the x in the other two equations. So here is that first one, or it's really the second one, but here's the first one I'm plugging into. Plus y minus 2z equals 1. Okay, now that's great. I'm just going to clean it up a little bit, so distribute out. Combine like terms, so -7y plus 2z equals -15. Okay, so that's great. That's this equation. And then I'm going to plug into the other one. Okay, same thing. Simplify down. And then combine anything that I can combine. So combine my y's, combine my z's, and move my 8 over. And then I'm going to go through and I'm going to write these as a system. Okay, now what I want to go through and do, just like we did earlier in the chapter, is I want to go through and I want to solve this system here. Now, from here on out, I don't care how you solve, pick substitution, pick elimination, pick whatever's going to be easiest. I think what I'm going to do, and let me use a different color here so it's easy for you to see, I'm going to solve this one for the z. So I'm going to move the 6y over and divide by the 3, -3. Now, the reason I picked this one is because I could solve for that z without getting fractions. And I don't like fractions. They're hard to deal with. Okay, so there's my z. I'm going to plug it in for the z in the other equation. Alright, all this work to get things in terms of y. Now that things are in terms of y, I can solve. So add the -12, and I'll get -3, y equals 1. Now, we did a lot of work to get that answer. Everything else should be easy. That first one's the hard part. So once I have the first one, then I can plug in here to get my z. Y is 1. So 2 minus 6 is a negative 4. Okay, so that's my z. Now that I have the y and the z, let me see if I can find another color, maybe pink. Then I'm going to plug in up here to get my x. I know my y. I know my z. So double negative makes a positive. So 2 plus 6, or 2 plus 4 is 6. Minus 4 is 2. So here then is my answer. X is 2, y is 1, z is negative 4. Now remember, it's always a good idea to check these because it's really easy to make a mistake in here. Actually, this is the second time I've recorded this problem because I made a mistake the first time. And so check your work. It's easy to make a mistake on these. All right, let's look at one more. Okay, so here's our second one. Lots of good things to solve for. I think I am again going to solve for my x, just mainly because I like to. If it's in the first equation, I usually pick it. You don't have to though. Okay, so point of doing that is I'm going to plug this right here in for my x's. Okay, so let me do that. So I have 2, here's all my x, minus 5y minus z equals a negative 2. And I'll go ahead and plug it in here. Negative x, there's my x. Now it is important that you remember these parentheses because that negative belongs to the whole x and all of this stuff is x. Plus y plus 2z equals 7. Now all I'm going to do here is clean these up. So I'm going to distribute. Combine like terms. Move the 12 to the other side. Okay, that's great. Same thing over here. And write them as a system. Now I'm just going to leave this one here and then I'll write the other one below it. Okay, so here's my little system. Now you'll remember I told you once you get here to solve this by substitution, we're doing our substitution here, here and here. So you don't necessarily have to solve this little system by substitution. Solve by whatever method's easiest, and there, those 3 z's will go away. That's what I'm going to do is use elimination here. So I have negative y equals negative 1, or y equals 1. Okay, so there's my first one. Then I'm going to plug in and get my second value. So I guess I'll just plug into this one. So I have 1 minus 3z equals negative 14. So I'm going to subtract the 1 and divide by that negative 3. So z is 5. Okay, I've got y and z. So I'm going to plug those in to this equation and solve for my x. And simplify down. So 3 minus 5 plus 6, so negative 2 plus 6 is 4. So here then is my answer. My x is 4, my y is 1, and my z is 5. There's my answer. Now, like I told you, lots of places to make little mistakes, so you do want to make sure that you're careful on these. because it is easy to make a little mistake. So solving by substitution with three variables.